Here's the definition of a radical. So the nth root of a is equal to y, where y to the nth is equal to a. When you are asked about the nth root of a, please examine the definition all the time, every time. So the colors here are meant to help that if the question is the nth root of a, then you should identify what n is and what a is. And then based on knowing N and A, so the thing in yellow and blue, you should set up a thing that looks like this here. Y to the nth is equal to A. So again, you'll know N and A because that was based on where the N and A were located in the question. And from that, you should fill in the blank. You should determine what Y is. Okay? And so that will then be our answer to what nth root of a is, and that will equal y. So let's look at many examples of this. Right here we have the third root of 8. Using the same colors as up here, the 3 here is n, the a in the formula is the 8, and y is the thing that we don't know, right? We're trying to figure out third root of 8, what number is that? And so we set it up to look just like this. Y, again, is the thing we don't know, but what's in yellow, that was the little number outside the radical. That becomes the exponent here, and we have 8. And so then stare at y to the third is equal to 8, and looking at that, you can see that y should be 2. Therefore, now that we know that y is equal to 2, this spot in the brown box is now filled with a 2. So to summarize what happens here, the third root of 8 is equal to 2 because 2 to the third power is equal to 8. Here's another one, the second root of 49. The second root of 49 equals y, which will be found from answering y to the second is equal to 49. That is, fill in the blank, raised to the second equals 49. And, well, the second root of 49 is equal to 7 because 7 to the second equals 49. We'll do the same thing, same process, just with different variables. So if you look at the previous slide, there used to be an A inside the blue box. Now it's a B, but where the B is located here in the radical, for the other equation, B is isolated by itself. It looks all the same, other than just different choice of letters. I did keep the colors the same. Let's simplify the fourth root of 81. To do that, the fourth root of 81 equals, we don't know yet, called Z. But how we find that is we set up this thing. Z to the fourth power equals 81. So think about that, stare at this, and go, aha, that spot here where the Z is, that should be a 3. And 3 to the fourth would equal 81, right? So Z equals 3 is what's going to fit. Z to the fourth equals 81. And therefore, the fourth root of 81 equals 3 because 3 to the fourth is equal to 81. We'll simplify the second root of 25. Second root of 25 equals z. To answer this, to figure out what goes where the z is, we set up just like what's up here in the definition of radical. Z to the second power equals 25, and you'll see that z has to equal 5. So the second root of 25 equals 5, and the reason is because 5 to the second equals 25. One more, go back to the original letters that were here, but it's the same definition. We'll simplify the second root of 1. Second root of 1 is equal to what? Well, it's answering what to the second is equal to 1. So just stare at that for a second. What to the second power equals 1. What can fill in where this y is, and that should be the number 1 again, actually. So this one looks a little funky, so stare at this one carefully. The second root of 1 equals 1 because 1 to the second equals 1. Now there's a lot of 1's floating around, but you'll notice in the equation before the word because and in the equation after the word because, there are 2 1's, and there's a blue one and there's a brown one, right? So the second root, that's in yellow, of the blue one equals the brown one because brown one raised to the second power is equal to blue one. Let's look at second root of 0. And the second root of 0 equals, we don't know yet, but it is found by answering fill in the blank, raised to the second is equal to 0. And we'll see that y has to equal 0 here. So we have second root of 0 equals 0 because 0 to the second power equals 0. Same thing with the colors. Let's look at the third root of negative 64. Now, don't let the minus sign freak you out. Just do the same thing. I think the thing is that students tend to be fine with second roots. But then you get to third roots, and especially with a negative, and people try to do all kinds of things. Just always go back to that definition. So we're using the same color scheme right now to help. The third root of negative 64 equals, we will find out what? It's called y here, but to find it, we need to set up y to the third power equals negative 64. And so this is a nice number. There is a certain number you can raise to the third power and get negative 64. You just gotta stop and work out a couple arithmetic calculations for a moment, and you'll see that that number is negative 4. Okay, so the third root of negative 64 is equal to negative 4 because negative 4 raised to the third is equal to negative 64. What we're seeing in this Q&A is an example of something that happens more generally. So based on this one example, I hope you'll trust or you can try out some more examples yourself. But the nth root of a is a real number if a is negative, the number inside the radical is negative, and n, the little number outside the radical, is odd. Now let's look at the second root of negative 64. Notice the slight difference here. Inside the radical sign is the number negative 64 for both the previous question and the new question. But the difference is the little number is the little number, which was this little n, used to be a 3 in the previous question. In the new question, it is a 2. So we should set this up all the same, typical way, so trying to use the colors to try to make this as consistent as possible. The second root of negative 64 equals y, where y to the second is equal to negative 64. And the point is there's no real number that you could put in the spot so that some number squared is equal to negative 64. There isn't a real number that's going to do this. And it's because when you square a number, that's multiplying a number by itself. A number times itself, and a negative times itself is positive, and a positive times itself is also positive. So there's no way that you could multiply a number by itself and result in a negative number. So you can't square a real number and get negative 64. And so here's an example of something that happens a little more generally. Just based on this one example, the nth root of a is not a real number if a is negative and n is even, right? So notice these differences here. This entire slide is trying to discuss the situation of what happens when the number that's inside the radical is negative. And then it depends on if the little number outside the radical, if it's odd or if it's even. And if the little number outside the radical is odd, then you can still get a real number. But if the little number outside the radical is even, then you don't get a real number. By the way, we will write root a as a shortcut for second root of a. So if the little number is missing, it's a hidden 2. Okay, so for instance, root 25 and second root of 25 are the same. Both of these say, and instead of saying second root of 25, we typically say square root of 25. We already saw that the square root of 25 is equal to 5, so root 25 is equal to 5. We already saw square root of 49 equals 7, so root 49 equals 7. We already saw square root of 1 equals 1, root 1 equals 1, root 0 equals 0. Given just one thing to be careful about, if you see root 25, it is incorrect to write root 25 equals plus or minus 5. We've actually not talked about this plus or minus symbol yet, but you might somehow attach that to the square root symbol, which is a bad idea. I understand why people would want to do this. We will talk about the symbol soon enough. The plus or minus sign appears in a different situation. We'll talk about that later. Root 25, by convention, simplifies to just positive 5. Now, just as a general story, when it comes to radicals or roots, people tend to be a little more comfortable with square roots, which is very natural, okay? But cube roots and fourth roots and so on, if the little number is not a 2 but is instead a 3 or a 4, you will still be required to simplify. And so try not to take square roots so much on an autopilot. Please try to go back and always look at the definition of radical.